Recording किया तो चलेगा ना इसमें?
Yes, ma'am, started.
Okay.
Started.
Yeah. So in the last class, I had started with the K-map minimization technique, and I had explained you how to represent two variable, three variable, and four variable functions using K-map. Then we also saw how to do. Let us continue with this today. So if you remember in my last class, I had said that K-map technique is basically based on it is based on combining theorem. That means if you have if there is only one variable which is changing, then you can simply eliminate that variable and you write the rest of the new product term is formed by writing remaining terms, right? So and in the K-map, we had seen that when the cells are adjacent to each other, we can basically group them together because adjacent cells, they differ by only one variable. So you can basically make group of combine the two cells together, and instead of having two different terms, you can club them together and you get a single product term out of it, right? This was the basic concept behind K-map reduction technique. Okay, so let me take one more example of four variable K-map. I'll show you there are basically various ways to group one cells, and I have already discussed few of the ways to group one cells. I'll take some more examples of grouping of one cells. Let's say this is the K-map of a four variable function. Okay, A, B, C, D, and you know how to label the rows and column of K-map. So you have to use gray coding 0, 0, 0, 1, 1, 1, 1, 0. 1, 1, 1, and 1, 0, right? And we know that each cell of this K-map represents a unique min term. And let me just write down the min term corresponding to each cell of this K-map. So first cell corresponds to min term 0, 0, 0, 0 means min term 0. Then the cell below this first cell is 0, 0, 0, 1 min term, which means 1. This is 2, this is 3, 4. This you have already seen in the last class, so I'll simply write rest of the min terms. 8, 9, 10, 11, 12, 13, 14, and 15, right? So this is the K-map for a four variable function. And if you remember, I had said that if you have two cells, two adjoining adjacent cells, you can combine them together and get a single term out of it, right? Suppose you have one cells in these four cells. Okay. Let me take another example. If you have four cells, now you have ones in these four cells, let's say. The function which I am trying to represent through this K-map is, if you have to write the function would be A, B, C, D, and I'm saying it is summation of 1, 5, 9, and 13. 1, 5, 9, and 13, right? This is what I have, this is the function whose K-map I have drawn here. Okay? So 1 will appear in the cells corresponding to the 1, 5, 9, and 13. If we solve it using Boolean algebra theorem, okay, let me just show you that here, so that we can relate it with this K-map. Okay, so that would be one means it's a four variable function, so four variables will be there in the product term. One means 0, 0, 0, 1. So A bar, B bar, C bar, dot T. Then plus 5, 5 means 0, 1, 0, 1. So 0, 1, 0, 1. Then you have 9, 1, 0, 0, 1. So A, B bar, C bar, D. And then you have 13. 13 means what? 1, 1, 0, 1, right? So 1, 1, 0, 1, right? So if you group these two cells together, 4 and 5, and 9 and 13, these two together. Okay? So grouping the first two. So what is common in this first two term is A bar. You see only one variable is changing over here. A bar, C bar, D are common. So only B is changing. So we can actually use the combining theorem. Okay, I'll simply write it. Okay. We can use the combining theorem and we'll say we only write A, C bar, D. Okay, D is changing. Okay. So by applying combining theorem, we get this, and The second one is in the second pair, A, C bar and D. A, C bar, D are the common terms. So you can apply combining theorem because what is changing here? The second term also B is changing. So you have A, C bar, D. Okay. Now if you look at this expression, we can again apply combining theorem here because only A is changing in this, right? So what you get is C bar D plus C bar D, right? So we get C bar D out of it, right? So what we have done exactly is that when you solve it using Boolean algebra theorem, you actually get a single product term, C bar D. Now same concept we are going to apply in K map also. What we'll do is we will combine. If you combine these two cells together, see, now you see clearly what I am doing. You are not supposed to see the. I'll show you how you are supposed to do it, but I'm just relating it with the uh, with the right hand side simplification. So if these two are adjacent cells, you can combine them together, and if you combine them, what you get is what you will get if you combine these two cells together. Yes, somebody can you say if you combine these two cells, if you make group of these two
C
cells,
bar, C bar,
what do
D.
you
A
get?
bar, C bar, D.
You have to see which variable is not changing, only those will come, right? So it means A bar, because A is not changing, it is 0, and B is changing. C is changing, D is not changing, right? So C and D are not changing, right? So C bar D, A C bar D, right? And if you combine these two, what do you get? You get A, B is changing, C and D are not changing, so C bar D, right? But actually, if you see here, a is if you compare these two now, you see we can again apply combining theorem, right? We can again apply combining theorem, and the resulting term will be C bar D. Okay. So what we do is that let me just go back. So it means that these two groups, they are also adjacent, right? These two groups are adjacent, and we can actually combine them together, right? So that is what we are going to do. Yeah.
Ma'am, you are not audible. Hello.
Hello. Yes.
Ma'am, your
Audible
voice
now.
is not audible. Yes, ma'am.
I told you that there is some problem with the audio. Uh, I am right now using my mobile because I could not. This smart board is giving some problem. So I'm actually using my mobile while taking the lecture. So 0, 2, 3, 4, 5, 6, 7. Yeah. Okay. So what we do is that we have seen just now I was showing that if we make two different groups, and because these two groups are also adjacent to each other, we can actually combine all the four cells together, right? So what we'll do, we will combine these four cells together. These four cells are adjacent cells and we can combine them together. Am I audible? Am I now audible?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
we can actually combine these four cells together, and the resulting product term would be, you have to see again the label of the K map. The variables which are not changing will appear in the product term. So which are the variables which are not changing? You see one is across all the column. So all the A and B are changing, right? What is not changing is variable C and variable D. So you get C bar D directly. Is this clear? So what
Yes,
does
ma'am.
it mean? It means that we can have a larger group of one cells also. So four adjacent cells can be combined together and you get a single product term out of it, right? Let me take one more example here. Okay. Let me take one more example. 0, 1, 2, 3. 5, 6, 7, 8, 10. I'm just discussing right now how to make groups of ones. Okay. So we are interested in forming groups of one. We have to see to it that all the ones are getting covered while writing the minimized expression, which I'll explain you later on. The procedure to get the minimized expression, I'll show you. But before that, you must understand how, in what all ways you can group one cells together, right? So let us say if the one cells are present, let's say. Let's say one is present at these 4 places. Okay. So you see, they are again, these are adjacent cells. Okay. You see, you can group these 4 cells together. Okay. We know that 2 cells, 2 neighboring cells are always adjacent, right? So you see here upper 2 cells, one at 5 and uh, in cell 13, they are adjacent. Similarly, 7 and 15 are adjacent, and these 2 groups are again adjacent to each other. It means we can form a larger group of 4 cells like this. Okay. And the resulting product term would be, you have to now see the label for all these 4 cells, which are the variable which are not changing. So you look at the label, the row label, we'll look at the column label first. So first variable is A. Here it is 0, here it is 1, so A is changing, right? For all these 4 1 cells, you have to see which variables are not changing. B is not changing. B is 1 here, B is 1 here also. So we will write B. Then let us look at the row label. So in the row label, variable C is changing. Here it is 0, here it is 1, but D is not changing. So you get BD as a product term. Okay. So when you combine these 4 1 cells, you get product term BD. Okay. So I suppose it is clear to all of you. What does it mean? It means that we can have larger group of 1 cells also. It is not that you have to make group of 2 cells only. 2 adjacent cells in the last class I said you can combine together because they differ in only one variable, right? Here what we are doing, you see there are two. We have seen that cell number 5 and 13 are neighboring cells, 7 and 15 are also neighboring cells, and the first group of 5 and 13, second group of 7 and 15 are also neighboring to each other. So we can form a larger group of 4 cells actually. Okay. So this group of 4 cells will give a product term BB. Okay. So I suppose it is clear to all of you. Yes.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now you tell me, can we combine? Let me take one more example. See, there are various ways to combine to make a group, to make group of 1 cells. So let me take one more. Let me take 1 or 2 more cases so that this point will be clear to all of you. So let's take one more example. A 16 cell K map. And let's say that let's say now ones are present at these 4 cells. Okay. They are present at these 4 cells. Cell number 1, cell number 3, cell number 9, and cell number 11. Can we combine these 4 together?
Yes.
Yes, ma'am.
We know that these cell number 1 and cell number 3 are neighboring cells. We know 9 and 11 are also neighboring cells. And these 2 groups are also neighbor to each other, right? So we can have a group of these 4 cells. If you remember in my last class, I had also told you one of the easiest way to find out whether the cells are adjacent or not. You just fold the K map. If you fold the K map from center, cell number 1 will overlap with cell number 9, right? Cell number 3 will overlap with cell number 11. So the overlapping cells are always adjacent cells. Okay, they are the neighboring cells. They differ by only one variable. You can compare it, right? If you compare cell number 1 and cell number 9, okay, what is cell number 1? Cell number 1 is 0001. That is A bar, B bar, C bar, D, and cell number 9 is A, B bar, C bar, D. So you see, they differ only with variable A, right? So one of the easiest way to understand this is that you fold the K map, whichever cells overlap, they are the adjacent cells. Okay. So we can have group of these 4 cells as well. And what will be the resulting product term if you combine these 4 1 cells? The resulting
B
product
bar
term
D.
will be B bar
D.
and D, right? Very
D.
good. P bar D is the resulting product term. You have to see which variable is not changing. Okay, for all these 4 one cells which are forming a group. Okay, so B bar D is the resulting product term. Very good. One more example. Let's say we have okay, 0, 1, 2. Let's say we have ones present in all the 4 corners. Here, 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 and here. Okay. Ones are present at cell number 0, cell number 2, cell number 8, and cell number 10. Can we make group?
Yes, ma'am.
Yes. If you fold this K map, you will find that these 2 will overlap. These 2 will overlap. We once again fold it. All the 4 will overlap, right? So we can make group of these 4 cells. Okay. Cell number 0 and 8 are adjacent cells, right? Cell number 2 and 10 are also adjacent. Cell number 0 and 2 is adjacent. Cell number 8 and 10 is also adjacent. So these 4 cells are adjacent cells and you can make group of these 4 cells. The resulting product term will be
P bar D bar.
P bar D bar.
P bar and P bar dot
P
P
bar.
bar dot B bar, right? You see what is not changing is B bar. You have to look at label for these 4 one cells. So here it is 0, 0, here it is 1, 0. 0 is not changing, right? So B is not changing. So B bar. And if you look at the row labels for all these 4 one cells, C bar, D bar, and here it is C, D bar. So D bar is not changing. So B bar, D bar is the resulting product term if you combine or make a group of these 4 one cells. Okay. It is also possible to make even larger cell of group of one cells. Let me take another example. Okay. Now suppose ones are present at 4, 5, 6, and 7. Okay. How will you group them? All of them can be grouped together, right? If the ones are present at 4, 5, 6, and 7 cells, as I've shown on the board, you see these 4 cells can be grouped together. Okay. When you can form a larger group of 4 cells, you should not form a smaller subset of it, right? It will be wrong if you make smaller 2 groups. If you make group of 4 and 5 and 6 and 7 and you say I'm covering all the one cells, no, it is not correct. When it is possible to form bigger group, you have to make a bigger group, not smaller groups like this. Okay. So a smaller group, which is subset of a larger group, is not should not be taken. Okay. So let me just yes. So we can make a bigger group of 4 like this, and what will be the resulting product term? Resulting product term is
P bar
A
D.
bar B. I suppose it is clear to all of you up to this, right? Now let me just modify this K map. Let's say you have a K map where there are ones in 8 cells. These 8 cells. Okay. Now you see, we know that we can make group of 4, 5, 6, 7. We can make group of 12, 13, 14, 15. So you get, and these 2 groups are again adjacent to each other. So you can actually combine these 2 groups also together and you get a bigger group of 8 cells. Okay. So you get a bigger group of 8 cells. And what is the product term now? When you combine 8 cells together, you get a single variable in the product term. And here it is B. You see, rest all the variables are changing. Only B is not changing, right? Please tell me if anything is not clear. Please interrupt me if you are not clear with anything. Okay. So you can, if there are 8 adjacent cells present in the K map, you can combine 8. You can make a group of 8 cells if they are adjacent to each other, and you get a single product term out of it. Okay. What if one is present in all the cells? In all the cells, one is present. If 1 is present in all 16 cells, then you can make a larger group of all 16 cells, and the resulting product term is 1. You get constant 1, okay, a fixed value 1. Am I clear to all of you? Okay.
Yes, ma'am.
So I hope it is clear. These are different ways to make group of 1 cells, okay. Now let us let me take a problem and let us now see how to simplify a expression and bring it into simplified SOP expression, okay. So having a knowledge of, how to make group of 1 cells, now we can proceed and see how to minimize the logical expression, okay. So let's do that. Let me take a simple example first. Let's say the example is a 3-variable function. Okay. You have to simplify this 3-variable function. Okay. I will let you know the procedure while I explain. In due course of time, you will understand the procedure also. Let me explain the procedure with the help of example. So let's say the function is a 3-variable function. So A, B, C are the variables, and the function is summation of min terms 0, 1, 4, 5, 6. 0, 1, 4, 5, 6. This is the problem given, and it has been asked to minimize this logical expression. This is the expression, and you have to get the minimized expression for this. Minimized expression means minimized expression, I'm saying. It means it should be in a reduced form, which cannot be, of course, in the most reduced form, which cannot be further reduced, and it should have minimum number of dead terms with minimal number of literals in each dead term. Okay, this is the motive. When I say minimal expression, it means an expression equivalent to this original expression, but it should have minimum number of dead terms with minimum number of literals in each dead term. Okay, this is the objective. So how will you do this? So the first step is, now we have to simplify this logical expression. The first step is draw the K map. Okay. So it's a 3-variable function. It means you will require 8-cell K map. So let us draw 8-cell K map. So I'm writing A, B on this side, C on this side, 0, 0, 0, 1, 1, 1, 1, 0. Label it like this. And then write the min terms inside at the top of each cell. Okay. So 0, 0, 0 is min term 0, 0, 0, 1 is min term 1, 0, 1, 0 is min term 2, 0, 1, 1 is min term 3, 1, 0, 0 is min term 4, 1, 0, 1 is min term 5, 1, 1, 0 is min term 6, and 1, 1, 1 is min term 7. Okay. Okay, now next step is to enter 1 cells in the K map. Okay. Normally now, whenever you are minimizing the expression and bring it into SOP form, we always look for ones, for what input combination output is 1, right? You remember this. I have explained this already, how to get the expression from the truth table. When you have to from the truth table, you can get 2 kinds of expression. One is SOP expression, other is POS expression. When your intention is to get SOP expression, you always look for ones at the output. Okay, you see which input combination is giving 1 at the output. And when you have to write the expression in POS form from the truth table, you see which input combination is giving output 0, right? So now we are minimizing it with SOP, right? Until now, we had been doing K map. I had been showing you the min terms. I had been saying min term, right? So these are min terms. So we will be getting minimized SOP expression out of it, right? Okay. So ones will come. So we have to focus on ones, right? We have to see for which input combination output is 1, and you have to enter 1 in those cells. So cell number 0 is 1. Let me just change the color of pen. Cell number 0 is 1. Cell number 1, there is 1. Cell number 4, there will be 1. In cell number 5, there will be 1. Cell number 6, there will be 1. So this is the function, right? This is the K map. It is okay if you don't show 0. In rest of the cells, what is there? It's 0, right? But it is okay even if you don't write 0 in the remaining cell. What is important is that you have to write all the ones which are present in the function. Okay. So this is the K-map representation of this function. Now, next step is to group the ones. Okay. Now, how will you group it? I have already told you whenever it is possible, you form larger group of one cells. Now, always grouping of one cells is in the power of 2, right? I said you can make group of 2 cells, you can make group of 4 cells, you can make group of 8 cells, or you can make group of 16 cells, right? So it is always in terms of raised to power 2. Okay. Now here, how will you make group? You see,
0, 1, 4, first and last column.
first 0 and 1 and 4 and 5, right? Very good. We can make this group of 4 cells together, right? These 4 are adjacent 1 cells. We can make group of these 4 1 cells. Okay. Now, in a minimal function, how do you, when you have a K map, when you have a truth table and you have to write the expression, how do you write the expression? In SOP form, you see which min terms are giving output as 1, right? Which combination of input produces output as 1, and you cover all those terms. You see all those min terms are covered in the function, right? And when you write this expression, the expression which I have written here in terms of SOP, standard SOP, canonical SOP form, it will be sum of min terms, logical sum of min terms, right? So you see, we see to it that all the ones are being covered, right? Similarly, in the K map, you have to see to it that all the ones are getting covered while writing the expression. Okay. So we have made one group, which is group of 4 cells, and the resulting product term is what is not changing? B is not changing. So B bar,
B bar.
only B bar, right? Rest all are changing. A is changing, C is changing, D is also changing. Sorry, C is changing, right? So you get B bar, right? Okay. Now this one is not covered yet. We have to see to it that the expression, the minimal expression, the expression, final minimal expression that we get should cover all the 1 cells, right? That is important, that we have to cover all 1 cells, right? We have covered these 4 1 cells, but this 1 cell is still remaining. So we have to group it with somebody. How can we group it?
By making.
So you always start thinking from larger group of 1 cells. Okay, we cannot make group of 4 cells with this one, right? So we have to go for group of 2 cells. So we'll make group of these 2 cells. Okay. So when you make group of these 2 cells, what do you get? You get
AC bar.
right? All the largest set of 1 cells. Now here, how many 1 cells are there? How many 1 groups are there? There are 2 groups, right? One is the group which gives you product term B bar. Other is the group that gives you product term A bar. These groups, these are the largest group that are possible, right? Can you make a group larger than these 4? No, we cannot make any group larger than this 4, right? Can you make group of these 2 cells are grouped together? Can you make a larger group of it, which will cover, these ones? No, we cannot make any other larger group, right? So this is the largest group which is covering this 1 cell, these 2 1 cells. And this is the largest group which is covering these 4 1 cells. So all the largest rectangular set of 1 cells, they are called prime implicants. Okay? Prime implicants. So how many prime implicants are there in this K map? There are 2 prime implicants. Prime implicants means the larger set of 1 cells. You may ask me, this group has only two cells. So is it a larger? Yeah, it is a largest group, largest possible group which will include this one. You cannot have a group bigger than this, which will include this one, right? So this is the largest possible group of 1 cell that is covering these 2 cells. So there are two groups which we have identified in this K map, and these are called prime implicants. All the larger group of 1 cells in the K map are called prime implicants of that function. Okay. So there are 2 prime implicants. Let me name it B bar, and second is AC bar. Okay. So the function, minimal function will be, we have to cover all the 1 cells. If I write only B bar, this one will not get covered, right? This one is getting covered by AC bar. So it means I have to include this AC bar term also in the minimal expression. So the minimal expression is B bar plus AC bar. Okay. This is what you get after minimizing the expression. If you don't minimize, how many product term will be there in the expression? If you don't minimize it, if you don't apply this K map, how many? There will be
5.
Yeah, there will be 5 product terms, right? Because there are 5 min term in the min term list. There are 5 terms. So there will be 5 product terms. Each product term consisting of 3 variables. Okay, it means just imagine how much reduction in the component we have done. 5 product terms, each having 3 variables. It means you will require how many? How many gates? 1, 2, 3, 4, 5. 5 AND gates. Each AND gate having 3 input lines and 1 OR gate, right? Well, on the other hand, we have reduced it to a function B bar plus AC bar, which means you require very less number of gates. How will you implement it? How many gates are required to implement this circuit? This is B bar. So you have B. So you get B bar, then A, and then C bar. That's it. This is C. So AC bar, 1 AND gate and 1 OR gate. That's it. Okay, this is the function. So you require only these many components. In fact, in most of the in most of the complex circuits, the logic style which is utilized there, we already have inputs with their complement form. Okay, so inputs are available in both true form and complement form. So in fact, this NOT gate which I have used will also not be required if the complement of input is also already available in the chip. Okay, so that's why I say this is it requires very less number of hardware as if you compare it with the original expression, if you implement the original expression directly using gates. Okay, so this is how we can get the minimized expression using K-map. But I'll take few more examples. Now in this example, what we have seen is that minimal expression is the logical sum of all the prime implicants, right? In this case, we have seen that there are 2 prime implicants and the minimal expression is obtained by having a logical sum between these 2 prime implicants. But this is also not always true. I'll take few more examples and it will become more clear to you how you are supposed to, reduce this kind of use K-map technique. Okay, but let me take one more simple example before I proceed to some complex problems. So let's say one more problem I'll take. Expression is it's a now 4 variable function. Let's say W, X, Y, Z are the variables of this function. And the function is, let's say 5, 7, 12, 13, 14, and 15. This is the function. Okay. So let us minimize this expression using K-map now. So it means we have to use 16 cell K-map to minimize this expression. It's a 4 variable function. It means 16 cell K-map is required. So let us draw the K-map first. W, X, Y, Z. 0, 0, 1, 1, 1, 0. And then let me also write the midterm inside the cell. So it is 0, 1, 4, 5, 6, 7, 9, 10. Next is we have to fill this K-map. Okay, now we have to focus on where we have to put 1. So ones we have to feed the cell with 1 value corresponding to midterms 5, 7, 12, 13, 14, and 15. So 5, 7, let me change the color of pen. So 5, 7, 12, 13, 14, and 15. So this is the K-map. Okay. Again, a very simple example. Now you tell me how will you solve it? How many prime implicants will be there in this function? Yes, quickly tell me how many prime implicants are there. Prime implicants are the largest group of 1 cells, largest possible group of 1 cell. Yeah, there will be 2 groups. Yes, one is the group which is formed by combining these 4 1 cells. This is one of the largest set of 1 cells, and the resulting product term is WX. And you see these 2. The another group is this. Right? This is another way to cover the make a group of ones. So this is another 4 cell 4 ones group, and the resulting product term is yes X. What is not changing? X is not changing and Z is not changing. Right? Right? So you see. Now we have to see to it that the minimal expression must include all the 1 cells, right? So now let me include this WX in the minimal expression. So I have included WX in the minimal expression. It is covering how many ones? It is covering 4 ones, right? These 4 ones are getting covered by WX, but these two cells, cell number 5 and 7, they are not getting covered by WX. It means I have to include the second prime implicant also in the minimal expression, right? So this is the minimal expression. You get the reduced form of expression as WX plus XZ. Isn't it very simple way to reduce the expression?
Yes, ma'am.
Yes,
ma'am.
Yes, ma'am.
In the two examples what I have just taken right now, we have seen that in these two examples there were two prime implicants and both the prime implicants were included in the minimal expression, right? We said minimal expression is logical sum of the two product terms, two essential prime implicants that we have obtained, right? So up till now, the two questions which we solved, we saw that all the prime implicants are included in the minimal expression, but this is not always true, okay? This is not always true. It is not necessary that you have to include all the prime implicants in the minimal expression. Let me take one more example where it will become very much clear. Let's say the expression is, I'll take again a 4 variable function. So let's say W, X, Y, Z are the variables. X, Z. And let's say the function is, it includes minterm 1, 3, 4, 5, then 9, 11, then 12, 13, 14, and 15. Okay. Now you please draw the K map. 1, 3, 4, 5, 9, 11, 12, 13, 14, 15. These are the minterms present in the function. Now, first of all, let us draw the K map. Okay. Please draw K map in your book. We require a it's a 4 variable function, so we require a 16 cell K map. So let us draw a 16 cell K map. So W, X, Y, Z, right? So this is the K map. Now we will fill the K map with 1 cells. So 1 is present in the cell number 1, cell number 3, cell number 4, cell number 5, cell number 9, 11, 13, 14, and 15. So this is the K map. Okay. Now you know how to
Ma'am,
form
12
how to
also.
form cells, right? Yes.
Ma'am, 12 also. 12 also. 12, 12.
12. 12 is also there. Thank you for reminding. Thank you for telling. Yeah. So this is the K map. Okay. Now start forming group of ones. How many prime implicants will be there? How many prime implicants are there? How many prime implicants you are getting?
4.
5.
4.
5, 5,
5.
5, 5.
3.
Right. Those who are
3.
saying, those who are
5.
saying 5 is correct. Okay. Let me show you all the prime implicants. Then yeah. The first prime implicant, this is very clearly visible. Group of 4 cells, right? This is the largest possible group of 4 cells, which I can see here. I cannot make group of 8 cells, right? You have to always look from the maximum number of biggest group, large. Okay? So we cannot make group of all 16 cells because 61 is not available in all the 16 cells. Okay. Can we make group of 8 cells? No. Group of 8 cells also we cannot make. Had it been 1 at this cell number 7, okay, we could have made this group of this as a group of 8 cells, right? But you see 7 mein to 1 nahi hai. So we cannot have group of 8 cells in this for this sum, right? But there are group of 4 cells available. One is this. This is one of the group of 4 cells. And the resulting product term for this is WX, right? Another group of 4 cells is these 4 cells, right? And what is the resulting product term? It is y bar dot z, right? Then we can also combine these 4 cells These four cells can be combined, and what is the product term? Product term is X dot Y bar. Okay. Which other group?
When
We
we
can
fold
have
the
group of
K map.
these
Ma'am,
four cells. Yes.
13911.
1, 3, 9. Yeah, 1, 3, 9, 11. You can have group of 1, 3, 9, 11, and the resulting product term would be X bar dot Z. Okay. So how many are there? 1, 2, 3, 4. One more group you can form.
Ma'am, but now all the ones are covered. So
Yes, all the ones are covered. But if you just do trial and hit method, all ones are covered and will stop, then how you will determine which group to use? Although all ones are covered, but I can also have a group like this. I can also have a group like this,
13, 5,
isn't it?
15.
This is also a group of four cells, right?
Yes,
A
ma'am.
group of four cells can be made from 9, 11, 13, 15. So how will you select which group to use, which not to use, right? What you are saying is correct. Already all the ones are covered, right? So we should not bother to make more group of one cells. But then how will you decide which
Ma'am.
group to take and which group to not take? Yes?
Ma'am, we will try to keep the number of prime implicants less, no?
No. Why?
Ma'am, means
Why you want
only
to
three group.
keep?
Ma'am, 3 group will be formed here.
Yes. Our intention is to have minimum number of product terms in the reduced function, right? That is true. And that is what we are going to do at the end. Okay. But right now, if you say that these three groups are sufficient to cover all the one cells, then how will you decide which three groups you are going to use? Because I will say to cover this 11, I will not use the group which is formed with prime implicant X bar Z. I want to use the group which is formed with 9, 11, 13, 15.
Ma'am,
Okay.
and
See,
it
if
shouldn't
you
matter,
remember,
right?
I had
It's
said
already going to reduce.
it is going to reduce, I know, but we want the minimized function and we want to know how many possible solutions are also there, right? See, our intention is to have some systematic method so that this method should tell us should tell us how many solutions are possible, and it should also give the reduced the minimized expression, right? Isn't it? So I'm trying to we are trying to uh, uh, set some a systematic approach. You see, now I'll tell you how you have to do it. First of all, you see, whatever number of prime implicants you can form, you have to form all the prime implicants. Don't limit the number of prime implicants. Okay, don't think that if you have lesser number of prime implicants, you will get minimized expression. You find out all the prime implicants. Later on, we are going to identify all the essential prime implicants which must be essentially present in the minimal expression. Okay, that we are going to do. Okay, so the first thing is you write down all the prime implicants, because we don't know which prime implicant to consider, which to neglect, right? You may consider this 9, 11, 13, 15, somebody will take some other group and cover all the one cells, isn't it? So we must know in how many ways the solution, how many solutions are possible, and if there is only a unique solution, then we should get that unique solution as well, right? So you have to consider all the prime implicants. This is also a prime implicant, and the resulting product term for this prime implicant is, what is the product term? If you combine 9, 11, 13 and 15, what is the product term that you get?
WZ.
Yeah.
WZ.
It is WZ, right? So there are total 5 prime implicants in this sum. Okay. Now I know that all prime implicants must not be included in the minimal expression, right? Because I know that few of these will be sufficient to cover all the one cells. So that is what I'm going to do. I will not cover all these. I'm not going to include all these prime implicants in the minimal function, right? Now we have to find out which one to include and which one to exclude, right? And for that, what we will do is, the next step is we will identify all the distinguished one cells, another important term. Distinguished one cells. Okay. So please understand first of all what is distinguished one cell. By the term distinguished one cells, I mean those one cells which are only getting covered by one prime implicant. Okay. All those one cells which are getting covered by only one prime implicant. For example, here in this sum, if you see here, the one present in cell number 3 is getting covered by only one prime implicant, that is X bar Z, right? Is there any other prime implicant covering this one cell? The one which
No.
is present in cell number 3? No. So this is a distinguished
ma'am.
one cell. Okay. And which is the prime implicant which is covering this distinguished one cell?
X bar
X
Z.
bar Z.
X bar Z. So X bar Z becomes an essential prime implicant. Okay. This becomes an essential prime implicant which must be included in the minimal function, right? Essential prime implicant. So I've introduced two terms here, distinguished one cell and essential prime implicant. Essential prime implicants are those prime implicants which covers distinguished one cells. Okay. So we must include essential prime implicant in the minimal function, that is for the sure, because otherwise those one cells will not get covered in the expression, right? Essential prime implicants are the only prime implicants which are covering those distinguished one cells. So if you don't include essential prime implicants in the minimal function, those one cells which have been covered by this essential prime implicant will not get covered in the function itself, right? So we will identify all the essential prime implicants like this. Okay. So first of all, let us identify all the distinguished one cell. Is there any other distinguished one cell? One present
The
in cell
one in
number
the fourth, the fourth cell.
the 4, right? This is also distinguished one cell. And which is the prime implicant which is covering this distinguished one cell? XY bar, right? It means XY bar is the essential prime implicant and it must be there in the minimal expression. We cannot skip this, right? This has to be there in the minimal expression. Any other distinguished one cell?
14.
14.
Yes, cell number 14. This is also a distinguished one cell because it is being covered by only one prime implicant, which is WX. So WX is also an essential prime implicant. Okay. So one thing is clear that the minimal expression must include these three essential prime implicants because otherwise these distinguished one cells which we have identified will not get covered by the minimal expression, right? So let us write the minimal expression now. So minimal expression must include these three essential prime implicants which are XY bar, XY bar, X bar Z and WX, right? Now let us find out whether these three essential prime implicants are sufficient to cover all one cells of the K-map. Let us identify that also. Okay. So let me just change the color. Yeah. Okay. So you see, the essential prime implicant XY bar is covering these four cells. I'll just put a tick mark. These four cells are being covered, right? By the minimal expression. Then second essential prime implicant we wrote is X bar Z. X bar Z is covering cell number 9, 11, 1 and 3, right? And the third one is WX, which is covering 12, 13, 14 and 15. So you see, all the one cells are getting covered by these three essential prime implicants. Okay. So this is a unique solution. There is no multiple solution for this sum, right? Because all the essential prime implicants are able to cover all the one cells. So this is the minimized expression for this function. This is the minimized expression. Okay. Is this clear? So what is the procedure? How we are doing? The first step is to draw the K-map, feed the cells of the K-map with 1, and then make the group, largest possible group of 1 cells. Each of these largest possible group of 1 cells are called prime implicants of the function. Then you identify all the distinguished 1 cells present in the function. And then you see which are the essential prime implicants or the prime implicants which are covering these distinguished 1 cells. Those essential prime implicants must be included in the minimal function. If the essential prime implicants are sufficient to cover all the 1 cells, then the minimal expression will comprise of all the essential prime implicants only. Okay. So unlike the previous two problems wherein all the prime implicants were the essential prime implicants basically, right? Because in the previous two questions we saw that the minimal expression has all the prime implicants because all those prime implicants were essential prime implicants. So here in this, I suppose it is clear how it has been done.
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Let us take one more sum, little variant. Yeah. Okay. Chalo. So the next question is, take down this question now. This is also of similar kind. And then I'll take one more variation wherein okay. So function is it's a core variable function and it includes midterms. Yeah, all of you please take it in your books. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 11, 13, 15. Please start solving this sum. 2, 3, 4, 5, 6, 7, 11, 13, 15 are the min terms present in the function. Okay. So the first step is we'll draw the K map. Let me do this sum. Okay, so W, X, Y, Z. How many prime implicants are there? Please solve in your book. So one will come in cell number 2, cell number 3, cell number 4, cell number 5, 6, 7, 11, 13, and 15. This is the key mark for this function. Okay, how many prime implicants? How many of you have finished?
5.
How many? How many prime implicants?
4.
5. 5.
5 prime implicants.
Four.
4.
Okay, let's do it. Let's see how many prime implicants are there. You can make group of these four cells together and the prime implicant is W bar X, right?
Ma'am, but a better equation would be with 5, right?
Huh.
So
You can make group of these four cells together and you get the prime implicant YZ. Okay. Next is you can make group of you can make group of these four cells together and you get a prime implicant W bar Y, right? And you can make sorry, and you can make group of these one cells as well, right? And you will get prime implicant X, Z. So there are 4 prime implicants, right? There are 4 prime implicants. You see, when you are forming, when you call a prime implicant, the largest group of one cells, right? So when you are forming group, you should see that the group should not be a subset of a bigger group. Okay. For example, you cannot make a group of 4 and 5. Is that clear? You cannot make group of 4 and 5 because 4 and 5, this smaller group will be subset of bigger group W bar X, isn't it? So that is not correct. Okay, but you can have group of 5, 7, 13 and 15. Although 7 and 5 are getting covered by some other prime implicant because 13 is not being covered, right? So you can have a group like this. But the group should not be a subset of any larger group. That is what this, the group of 5, 7, 13, 15 is not subset of a bigger group, right? It is a different group. I think I am clear about this, right?
Yes, ma'am.
Okay.
Yes,
Now the
ma'am.
second step in solving, minimizing this K-map is to identify all the distinguished one cells. So let us identify all the distinguished one cells quickly. So how many distinguished one cells? You see cell number 2 is a distinguished one cell, right? Cell number 2 is a distinguished one cell because it is being covered by only one prime implicant, which is W bar Y. So this W bar Y becomes the essential prime implicant. Okay. Cell number 11 is also a distinguished one cell because it is being covered by only one prime implicant, which is YZ. So YZ becomes the essential prime implicant. Cell number 13 is also a distinguished one cell. It is being covered by XZ. So XZ becomes the essential prime implicant. And cell number 4 is also a distinguished one cell, which is covered by only one prime implicant, which is W bar X. So W bar X also becomes essential prime implicants. So there are 4 prime implicants in this K map, and all the 4 prime implicants are essential prime implicant. It means the minimal expression it must include all the 4 essential prime implicants. It means the minimal expression must include all the 4 prime implicants, which are essential prime implicants, right? Because they are also essential prime. So we have to include all the 4 prime implicants. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay.
We have IBM.
Yeah. What's the time now? One or two. Only two more sums I had planned to take because there are some little
Ma'am, we
different
are
types.
awake since
Ma'am.
8.
Yes, ma'am. We are
Ma'am, we are awake since
saturated.
8 and we have lectures at 5:30 then.
Okay, fine. Then I will give you 2 sum. You take it as a homework and solve it, and let me see. Tomorrow we'll discuss. Tomorrow means whenever is my lecture again. Okay.
Okay, ma'am.
So please take down these 2 sums and try to solve it. Refer what I have explained, and based on that, try to solve these 2 sums. First one is a 4 variable function, and the function includes min term 0, 1, 2, 3, 4, 5, 7. Visible?
Yes, ma'am.
Yes,
Is
ma'am.
it visible?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes,
Please
ma'am.
take down these two sums and solve it as in homework. Okay. First function contains minterm 0, 1, 2, 3, 4, 5, 7, 14, 15. And the second function includes minterm 2, 6, 7, 9, 15. Okay. Okay. Wait for a moment. I'll take attendance and then I'll leave you people. I'll take attendance. I'll tell you once I take the attendance. Please wait. By the time I'm taking attendance, you can solve this question. Please wait for some more time. There's some technical problem while taking attendance also because I'm using mobile handset. In mobile, lots of features are not visible. Give me some time. Okay, students, I have taken attendance. You all can leave now.
Thank you, ma'am.
Thank you,
Bye.
ma'am.
Okay.
Thank you,
Yeah.
ma'am.
Bye. Take care.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. एक शिक्षक